Okay, so for number 2 of the review, the first review, but number 2 of that problem, it has a robot that fires. It's basically like a pitching machine type thing. It fires a little beanbag at a specific velocity, so it's tuned that from the height of that it's set on the robot, it drops a certain distance right into a target. It's perfectly calibrated so it always hits its target. And if it hits the target, it's 4 points. If it goes a little bit farther, it's 3 points. If it goes too short, or it's 2 points, and it kind of goes farther and farther out until it's 1 point. And if it's past those things, there's no 0 point zone as far as I know. Hopefully it doesn't fire backwards. But it says in the problem that you get to the competition and you realize that the height is now half the height. So it's not going to go the same distance that you wanted it to. So you're asked to explain whether you would fire it at the original velocity or double the velocity to get the most points. Okay, so what I want to do first is kind of think about this problem. This is a projectile motion problem, but it's the easier kind of projectile motion problem where it's just firing it directly horizontally. So directly horizontally, it means the horizontal motion is constant throughout, and then the vertical velocity is only what you get because it's accelerating by gravity. Okay, so if we look at part A, it says to graph. So I'm going to do that once again on the graph paper here. So it has the same setup. So Vx, I'm going to call this point here V0. The nice thing is, until it hits the ground, that velocity is constant. I'm going to say at this point is where it hits the ground. All right, so it gets there, the velocity is constant. The vertical velocity starts out at 0 because it's only fired horizontally. But then as soon as it's fired, gravity starts to pull it down. So what happens is that velocity becomes more and more negative. And so the slope is negative 9.8 meters per second squared. So it goes negative because it's going toward the ground. So that's what you're trying to show there. So it's a pretty simple, pretty straightforward graph. You could get a good number of points just by knowing how that works. And I can guarantee you that on our final exam or on our the AP test, they'll have something related to this because that's one of the things that shows up all the time in physics. So based on all of this, we have to figure out, so when it says to do a paragraph length response, what you need to do is actually figure out the answer first and then write it in a paragraph. So because it's firing horizontally, we know the horizontal motion doesn't change, but the time in the air definitely does change. So if I look at that, I use my vertical equations of motion, but the initial velocity in the y direction 0, and it drops by a height of negative h. So my original time is just what I would get by solving this for the height h. They don't give you a number, so we have to leave it as a symbol. So my original height, the original time that it takes to hit the ground, is the square root of 2h over g. Now that should be fairly familiar. We did that a number of times last semester, especially Unit 2. You can go back to look at that type of stuff. So now, for the new time, we take the same thing, but now instead of dropping a height h, it drops a height h over 2. So if we look at that, we solve, multiply both sides by 2, divide by g, take a square root. We find out that the new time is the square root of h over g. But the original time was the square root of 2h over g. So my new time is 1 over the square root of 2, or root 2 over 2, times the original. So it's going to be about 70% of the original time, 1 over the square root of 2. So it's in the air, but it's in the air less. So now we have to figure out what's going to happen. So the original distance it goes is just the original velocity times the original time, and it goes a distance d. If you fire it at v0, you would find out, because the initial velocity is the same, but the time is only 0.7 as much, you end up with 0.707 times d. And if you go back to the diagram, you see that gives you 2 points. Case 2 is where you fired at double the velocity. So if you double the velocity, the nice thing is with the horizontal distance, you're just going to double the distance. That's 1.4 times d. That's less than 3/2 d, so that gives you 3 points. So firing at double the velocity gives you that. So what you need to do is, in 3 to 5 sentences, explain that. Talk about how the time in the air changes because it's now at a lower height. Use that to explain what happens to the distance. You can put in your equations, you can put in the results. And then the final thing you need to do is talk about, because it's not asking about the distance, it's not asking which one's closer, because in reality the 0.707 is closer to the target, but it's in the 2-point zone instead of the 3-point zone. And they're not asking about which one's closer, they're asking about which one scores the most points. So you need to be able to go back and say it's equal to that. So like the first sentence, you just talk about, because the robot's firing from a lower height, it will spend less time in the air, and then you can talk about how far it goes in each of the cases, and then talk about why one of the cases is the best. Just kind of a standard paragraph that you're putting together there. So make sure you're able to explain what you're trying to do.